Ladies and gentlemen, legacy code is one of the biggest pain points of all software engineers. Today, with our pre-sales engineers and software architects, Kacper Świętkowski and Krzysztof Sikora, we will discuss how to make onboarding of a legacy project from one team to another possibly smooth. Gentlemen, I'm super glad to have you here. How are you doing?
Doing good. Thank you, Michael.
Good. Thank you for having us here.
Yes, today's show will be super transparent because we all decided not to blur our backgrounds. Oh, I think that Krzysztof blurred his background.
I'm blurred.
Never mind. Okay, let's talk about the legacy. Please tell a few words about the characteristics of legacy projects. I mean, they may sound obvious. What is, let's say, the main difference between working on a greenfield project and something, let's say, legacy related? But how does it look like from your perspective?
So to me, the most important part is actually to understand why the current vendor is going to be replaced. What are those issues? And if we can actually fix them and perform better, because that's the most important part. If I can identify those issues easily, propose solution that I know that I can deliver the quality or the value to the customer, and this is like the most important part. To me, obviously, the difficult part is actually to correctly identify those issues. Very often, customer can only see the tip of an iceberg, and the underlying causes are not that clear at the first sight. But this is basically our approach when it comes to legacy code.
All right, Krzysztof?
Yeah. So kind of addressing your question, what is legacy? I think it can mean different things. I mean, some people say that once the code is written, it becomes legacy. But I mean, usually, I guess we talk about systems that have been around for quite some time, like 5 years, maybe even a decade. And I would say I usually kind of sense a legacy system coming our way when you see certain indicators, like people say, okay, no one wants to work on this system, or like we lost key developers, or it's very hard to change, or there are outages or problems that the customer or the owning team cannot really identify. So I think we could go on and identify a set of indicators that can really classify a system as a legacy that is not actively kind of maintained and is rusting with time more and more.
So what do you consider while reviewing potential projects for handover? Do you analyze performance, security issues, market-related value? How does it look like?
First of all, I would consider like success criteria. So everything that you said is obviously important, but I usually there are already some pain points that are recognized by the customer, and understanding what's need to be fixed and what are those issues are like the most important one. For some, it might be performance. For something else, that there might be security issues or some outages, as Krzysztof said. It's very difficult to give you just one answer for every case. So there's usually process of understanding the current situation of the client and proposing a solution for that.
Yeah, from pre-sales perspective, I cannot really stress more understanding the current business situation of the customer. So where they are at the moment, what problems do they face? What is their like long-term strategy? Are they willing to expand the business? Do they have specific needs or requirements with regards to the system? So I think understanding this is really key to decide on further steps, and only then we can go into technical analysis of what the system is, what the tech stack is, doing code reviews, and maybe analyzing the kind of further requirements. Because sometimes we see that the customers jump into conclusions and do not really do this analysis upfront, and they want to have a new system, which might be the eventual decision that is to be taken. But I would really encourage and take the time to properly understand what is the problem and what is the goal.
So
to give you an
please.
example, a customer may be not satisfied with the velocity of the team, so the pace that the current team is working on a software. But actually, the root cause for that can be organizational. So, for instance, there is an increasing amount of technical debt, and that makes the current team slow. Maybe the maintenance cost is growing, or maybe the code and maintainability is very high, and sometimes there are even like HR issues where a company cannot rotate properly, and if the project lasts for multiple years, many years, you can expect people change over time. And then there are like many issues, like lack of documentation might be an issue, like lack of new talents and the ability to gain new talent and onboard new talent to the team. Sometimes the issue is with the growing number of the team members. So when the platform was small and the team was small, it was quite easy to develop. Right now, because of the sheer amount of the line code that is already been written, changing anything may be very difficult. And the issue is actually in the architecture. So there are like many root causes, like plausible for a simple pain point, which is the team is not delivering in the pace that will satisfy us, which maybe it's not like longer feasible from like ROI perspective.
Okay, so it's not, let's say, just an engineering challenge. This may be a decision of a personal or business background. Does it mean, let's focus on the business aspect. We are about to take over a project that is a legacy project, and we recognize business issues. Is it beneficial to involve in such process someone, let's say, from user experience team, like someone who's doing research, like a business analyst, that kind of person?
Obviously, it depends. So if this is like backend system, which is going to integrate to backend, like third-party systems, maybe the UX is not needed. But sometimes, yeah, you can eliminate much of a customer support that is needed, just improving the UX. So there might be a situation when the current team is overwhelmed with the customer support that is needed, and you can solve that with improving UX. Okay, so this is totally possible, but this is just one of possible branches how the current situation can be fixed.
Yeah, and I can kind of counterbalance this with an example from the past where a key part of conquering a legacy system rewrite and transition was to have a proper business analysis done, because a system that initially was mainly used by the customer care turned out to be so much kind of connected into many departments like finance, reporting, kind of even daily operations of the company, that from one stakeholder, the project turned out into like a stakeholder board project, because there were so many things not really seen initially in the UI level, for example, the system was used as a compliance. It was used for financial purposes in terms of reaching a compliance in the bookkeeping. So things like that can really surprise you. So speaking about more complex enterprise types of systems that have been around for decades, and usually each company has such a system that was written in the beginning and was covering many different areas. These are really interesting cases. So proper analysis and then really splitting away different parts of the system to satisfy new business requirements is one of the ways to go. And that's sometimes the reality.
Okay, then. Thank you very much. We talk a little bit about the business aspects, personal aspects, but let's focus now on engineering. Very often when we take over, even at the pre-sales stage, a legacy project, we conduct a code review. Yes, we take a deeper look into the repository that is shared with the client by the client, and we tend to analyze to get at least some very initial orientation. Are there any good practices that a person conducting code review should follow? Are there any, let's say, advices that you would be able to give? What we need to remember about while conducting a code review?
So I would say that first of all, you need to understand the limitations of code review. So not everything may be included in the code review. To give you an example, you can have exactly the same query that retrieves a user from a database which contains 1,000 users or 100,000 users, and the system is completely different. And the complexity operating on such a system is totally different. So this is one thing. The infrastructure and the context of the software is very important. So that being said, for instance, if you've got a software that is used by a desktop employee and is going to, I don't know, make some reports quarterly, and it crashes like once a year, it may be painful, but maybe this is something that is acceptable. But on the other hand, if you've got a train company and your software causes train to crash once a year, this is like completely different requirement for the code quality. Like prior to code quality, we need to understand the severity of certain issues, and then we can assess if given code will be sufficient enough to be actually a solution of a problem that is stated. So this is one thing. And later on, like obviously you can focus on some smaller issues like how the database is handled. Is this something that is readable? Very often, during the transition period, you may expect some walkthrough of the code, but you need to remember that this walkthrough is going to be done by a company that maybe is not that interested into you understanding fully what's going on. So at the end of the day, you need to make sure that you'll be able to understand what's written in this code. So this is one thing, and one very important I would say issue that may be understood from the code is actually third-party dependencies. Very often they may be not documented, and it's still so much easier to understand what's written in the code base that you have access to comparing to using some other services that may be legacy as well, and they are not documented and you don't know how they work. They are not built by their team that you're going to replace. So this like these aha moments are actually what we're looking for. Okay, some external dependencies that no one is actually aware of, even the customer itself.
When you've been saying about the train companies, I kind of remind myself that about this advertisement that was released recently, that the German state railways, they've been looking for a guy knowing Windows 3.11 because their schedules and everything is still relying on floppy disks, yeah, and they needed someone who basically knew the technologies that had been commonly used 30 years ago, but and they couldn't give it away because it works, yeah, and they are super afraid of even touching it.
Yeah, risk management is a huge part of taking over legacy platform. That's for sure.
Mm-hmm. So sometimes we can do more damage than solution. So we need to be aware of that. Okay, then. Speaking about legacy, speaking about more engineering aspect of legacy, what about moving from monolith to microservices architecture? We get more and more requests of that kind, and sometimes we are surprised learning that in some projects this is not a necessity and it's not even recommended. What is your thought about moving from monolith to microservices?
I think it's usually a buzzword for many people. Like any of the patterns that are high level, might be serverless or whatever, and they have heard it. Maybe it worked for a company they have been talking to, and they've looked at the upsides and the benefits, and they want this to happen with their system. So as has been already said, there is no one solution fit all, and we would usually again go back to square one and analyze what is going on with the system, what is wrong, and if really microservices might be a solution, and if it is, like it looks that this might be a solution, we would really very rarely advise to split a monolith into microservices and define as a project goal. We would usually mix the current business opportunities and challenges with introducing new services, and then maybe splitting away, like peeling the current system from features. So this would be this kind of evolutionary approach into the architecture. Unless this is really an obvious case, which is very rare. So we have seen so many microservices architectures going wrong, and this is also quite there's also quite a good amount of proof in the literature that with that, as any other high-level architecture or a product, you need to be really careful.
Yeah. Okay. So what I can add to that is that like having microservice architecture is not a property of the software. So if you want to consider like architectural drivers, and this is like maintainability of the code and scalability of the code, and then you can actually say if those markers are going to improve because of that, or the other way around, we will introduce unnecessary complexity to the problem. Some indicators that microservices might be a good approach would be, for instance, growing team size, and you no longer can operate and merge between each branches is going to take forever, and it's very difficult to handle team of maybe 20 people. Then we might split the monolith architecture to smaller teams that are more agile, more they can go faster. The other way, other consideration is actually risk handling. So imagine that you've got your legacy platform and you want to rewrite that. As you said, sometimes it's very difficult from the risk, from the perspective of the security of the platform to rewrite everything at once. So what you can do is split the current software into like smaller pieces and rewrite piece after piece. So with this approach, there's like much lower risk that you will fail tremendously. Okay, so you limit the possible like burnouts. Like with the smaller project, every risk is reduced as well. And the second part is scalability. Very often, if you've got like monolith platform, you'll end up with one database, which usually is bottleneck when it comes to writes. So if this is the issue, then probably some approach like CQRS might be useful. So you can actually split your platform and scale the pieces of the platform independently. So that is proved to be a very effective approach, but only when it's needed. So the main con to the microservices is increased complexity and the amount of communication between the microservices. So definitely it's not a silver bullet that will fix every software.
I hope you enjoyed the first part of our conversation on legacy projects. We decided to cut this episode into two, and additional questions will be asked in the second part. Thank you. Have a great day.